Hello everyone. Welcome to our YouTube channel KIIT Robotics Society. It's me Rohit Mundra, student coordinator of KIIT Robotics Society. I welcome here you all to in a webinar for the Konquest. So first let me introduce KIIT Robotics Society to you all. So KIIT Robotics Society is a society for robotics in KIIT. If you are a KTN, you must know we are at 25-year celebration. We are here are celebrating KIIT at 25, Silver Conquest. This is the event where we are planning to have three robotics events. That is Ideathon, Line Crawler, and RoadRunner. So this is the webinar we have organized for you all to know about RoadRunner, that is manual bot, and line crawler, that is line follower. So here we will be teaching you how to make a line follower, how to make a manual bot, and how you can go for it and participate in our competition and win exciting goodies and exciting cash prizes. So first of all, I would like to introduce Purendra Viswakarma, who will be teaching you about manual bot. I would like to introduce Ayandip Datta, who will be teaching you how to make a line follower and all things about line follower. Now, I would like to tell you that we are here at after a long period of time. So please like, subscribe, and share our YouTube channel that everyone can know and everyone can learn something from this event. So here we begin.
Hello guys. Hello everyone. Good morning. A very beautiful Sunday morning. So, as Rohit introduced myself, Purendra Shakarma, a member of KIIT Robotics Society, and today in this session we are going to learn how will you make your first road runner or basically a manual bot from a very scratch. Okay. So starting with just let me know how many of you are aware of what is a manual bot. Okay, just raise your hand or say yes or no in the chat box, in the comment section. Okay. So, in the very layman terms, okay, if we see what is a manual bot, okay, with the competition point of view. So, what does it signify? Well, what does it means actually? Okay, a manual bot is basically nothing. It's a radio control, either wired, wireless bot, which you design based upon the dimension constraint given by the particular college or university, based upon the competitions, and you make the competition in that way. Okay, just similar. It's just a four-wheel drive bots. Okay, either four-wheel drive, six-wheel drive depends upon the constraint, dimension constraint, weight constraint. Okay, uh, both the things will work, either four-wheel drive or six-wheel drive. Okay, so here in this tutorial, in this video, we are going to learn how will you make a wired and wireless bot both. Okay, starting with so the components that we are using in general in a basic wired board. Okay, so as you know about what is a four-wheel drive, just think in a four-wheel drive board. Okay, comment section, comment section. Okay, just comment down how many of you are familiar with the F1 racing, the Formula One. How many of you have seen that? The top racing cars race among the fastest tracks of the world. How many of you are aware of that? Just let me know in the comment section, guys. Hush, hush, hush. Okay. Okay. So we are basically focusing in this tutorial, we are basically focusing on a four-wheel drive bot. Okay. So what does a four-wheel drive bot signify? Well, what does it mean actually? A four-wheel drive, as the name says signifies, the bot contains with a four wheels. Okay. 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 So a stick. Okay, you know about that four-wheel drive. Cool, cool, cool. Okay, okay. Any other who will know about that four-wheel drive bot, manual bot? Cool. So in this, so starting with a four-wheel drive bot. So what does it mean? A bot with a manual bot. Okay, a bot with some four-wheel drive system containing some motors and a ziggles of wire, a lot of wires. Okay. Now, since we are starting our session with a wired bot. Okay. So in a wired bot, basically there is a bot with a four wheels, simply a four wheels chassis. Chassis is that in which you assemble all the stuffs together and you make your complete whole structure of the bot. Okay, the chassis of some four wheels, some motors, and a hell lot of wires. Okay, for the so since this is a manual control bot, you are controlling them manually. So at that point, there is some a remote which is made up of some switches. You use that switches to control the direction of the bot to move it forward, backward, left, right, in which direction you want. Okay. Now, uh, before starting with a wired bot, there is a interesting thing which I want to convey. It's that wired bot and wireless bot. What is the basic difference between these two? What does a wired bot and what does a wireless bot means actually? So, see, wired bot contains only wires actually. There is no brain. You, the brain is with the controller. Okay, he was controlling the forward, backward, left, right, whatever direction he wants. But the main brain is with the controller. Okay, in the wireless bot, it has some kind of brain. It has some microcontroller, a driver, anything else. Hell, other thing. Means it like you can make a wireless bot to run by itself. It will complete the whole track with a certain amount of time by itself only, like a Tesla bot. See how interesting it is. You make your own Tesla with a controller. That we will go it later. But with a competition point of view, we are starting with a wired bot. Okay. So as you can see in the presentation, uh, the simple wired bot, what does it requires? A chassis. What does a chassis means? Chassis is anything that where you assemble all the parts together. Okay, it can be made up of the metal, ply, sunmica, metal, ply, ACP sheet, aluminium sheets, made up of anything. Okay, will the parts be provided by the society for making the bot? Okay, cool. Sanskar. Sanskar, may I know your in which year you are? Just comment down. And for the for the parts, you can contact the society members. Okay, no issues. If you want, if you are interested in doing that stuff, you're interested for second year, cool enough. Okay, if you are interested, you can form a team of 3 to 4 people, and we will help you to we will surely help you to provide the parts. No issues. Okay, you can reach out. You can contact us. You can contact our coordinators. Any member you can contact. Okay, we will surely help you. Okay, moving forward. Any questions, guys? Here, you have any question? What is a wired bot? Any? Since okay, just let me know how many of you are the beginners in this field. The first ones who haven't designed any bot yet. I have made the team for the RoadRunner. Okay, okay. So Sanskar, just let me know. Do you have your parts? Okay, you have the component list. You have all other stuff. When can the first year student join the society? Okay, okay, okay. We will answer it soon. Okay. No. Okay. Contact with our team members. Okay, Sanskar. Just contact with our team members. They will surely help you. Okay, no issues. You can find the numbers on the posters or in the hanging posters itself in the electronics building at anywhere. Okay, you can find the posters and contact them, and we will surely reach out to you. Okay, cool. Any questions, guys? Here, any questions? Okay, wired bot. Cool. See, earlier we have discussed now. What is a wired bot? A wired, okay, wired and wireless. See, go by the term, go by the simple terms. The name itself signifies wired bot. The bot with only wires. Now there are wires also. Matlab, in the wireless bot also there are wires, no issue. But the wired bot is purely depends upon the wire. Okay, there is no brain, no controller, just a motor, a power. You have to push it forward, backward. You will provide the power at any point of time through your switches, and you can control the directions. Okay, in the wireless bot, you there is in the also in the wired bot now there is a long approximate 2 meters something like kind of long wire between controller and your bot. So you have to hang by you need another person also to hold that wire and in the big antenna. Okay, but in the wireless bot, what's the advantage is like, see, in the wireless bot, na, there is no, it's like a RF signal. Okay, how many of you have played with the PS3, PS4 type of controllers? Just let me know. Okay, we will inform you, Priyanshu. No issues. Okay. Okay. So it's like a no, it's like a PS4 controller. Okay, you control you have the remote, you have the controller in your hands. You control the directions. But since the PS4 is virtual playground, it's not virtual. It's a real life playground. Okay, you control the board by controlling that direction. The joysticks is like in your thumb. You can control the direction forward, backward, left, right, anywhere, any direction you want in the wireless bot. There is a bot of some certain dimensions. You can control it by your. You can control it your PS4 controllers. You can search it on Google. Okay, you can find a hell lot of tutorials. You can use your PS4 controller to control that bot. Okay, okay. So moving forward, let's discuss something about a wired bot. Okay, what's the component we are using in wired bots? Okay, back to the track. We have discussed about chassis. The chassis you can made using the ply, aluminium, basically anything. Okay, metal, anything. But there is a point actually. Now, in most of the competitions, now you've seen there is some weight limit actually. Okay, let's say weight limit of 2 kgs, 3 kgs. Okay, just let me know in the comment section how many of you were gone through the problem statement of the rules of the Conquest Roadrunner. Just let me know in the comment section. How many of you were registered for the Conquest Roadrunner, or you have gone through the rules and regulation, etc. of the Roadrunner in the Conquest? Okay, not yet. No one, no one has gone through. Why? Yeah. Okay. Arsalan Salim. Cool. Okay. So as you can see in the column statement, na, in the rules and regulations, actually, we have mentioned that there is a dimension constraint of 30 cross 15, and the weight constraint of 3 kgs. Now, in the most of the competitions, such as if you earlier we have also moved to IIT KGP or in the IIT Kanpur, there is a weight constraint of 2 kgs. Okay. So most since the total bot, including the battery, also it's not more than 2 kgs or 3 kgs. In our case, it's 3 kgs. Okay, limited to 3 kgs. Now, what happened? Uh, since the weight is about not mostly, but about 20 to 25% of the depends. The weight depends upon the material through which a chassis is made actually. Okay, so let me show you a bot designed by our team actually, which is also going through that IIT Kharagpur in the recent Tech Fest. Okay, if you see here now, just a minute. Okay, if you see here now, this is the body made out of the aluminium bar actually. It's not that it's not it's very hard aluminium. The aluminium which we are using in our homes, that for the doors etc. we are using. It's made the chassis is made out of that only. Now what? Now why? Now the chassis, the choosing of material for the chassis is your first thing actually. Okay, since about 25% of the weight depends upon that chassis. Okay, what happens now? Why we are choosing this chassis only? Now in the market also there are metal chassis which are lightweight, no issues. Okay, choosing of this chassis is because we choose this chassis only because since this is uh, we can easily we need a compact bot. Okay, now the much compact your bot is, faster it will run in the arena. Okay, larger the dimension, larger it will take the time to complete the whole track actually. It will take around in our tournament the time is given around 7 minutes to complete the whole arena. Okay, now if you make a bot of something large, big in size, something like that, it will take a. Okay, wait a minute. Can you please show the bot again? Okay, cool. Okay, see, this is the bot. It's we have designed this bot for our tech for the IIT Kharagpur Tech Fest. This part of the just a minute. This part, this is the chassis. Here are the motors, which is the open area. This is the chassis. It's made up of the aluminium bar. The upper portion has been cut out. Okay, and we have turned it around in a 90-degree angle. See. Okay, okay. Moving forward. So okay, we will discuss it later about how you can choose the material and stuff, etc. Okay, the components, chassis we have discussed. Now the other thing is motors. Okay, motors in the wired board, in the wireless board also there is a motor. In that, another thing is wheels. Wheels, some rainbow wires. Okay, not rainbow wires is not compulsory. You can use any kind of wire, but rainbow wires is preferable because there is like for, to know about which wire is going through which direction, something like that. Or positive goes to positive, negative, black and red wire, etc. Help. Okay. Now, these are the things you require to complete your bot. Okay. Okay. Just for the bot, you require chassis, motor, and the motor clamps, L-shaped clamps. You can easily get it in any store, any robotics store. Okay. L-shaped clamps and some wire. For the controller in the wired board, you need DPDT switches. Okay. Now, what does a DPDT switch means actually? The DPDT is like double pole, double throw switch. Okay. At the in a single switch, you can control two directions. Okay. There are it's like 3 point switches: neutral, positive, and negative. Okay, so you can control a three transmission at the same time using a single switch. Okay, DPDT switch case work to just to showcase that, just to put the whole controller in a single box so that you can easily use it, no issues, without any issue. Last, power supply. The power supply is the most important thing which controls for your which is for your bot actually. Okay, the power supply is like the main memory, not main memory. It's like a strength for your wired bot. Okay, Now, most of the people nowadays, what they are using actually, now, no, most of the people, what they're doing actually, now, they're using like that lithium ion type of batteries. Okay, see, using of AAA battery, using of lithium ion battery is not much sufficient to power the your motors actually. Okay, or in the local markets, if you now since for the conquest point of view, if you see, we have very short duration of time left. Okay, now in this period, if we search for the with the best motor, now most of the people will go for the local shop and buy the motors about a certain RPM, certain torque. Okay, what they're doing, the motors which are available in the local market, it's very cheap motors. Okay, it's from the second and third hand vendors, so it's not quality motors. Now that it's written that there is 300 RPM, but it's not actually 300 RPM only. It's vary about 400, sometimes 200, sometimes 500, anything it will vary. Depends upon the specification of the motor. You have to choose your power supply. Now, most of the times in the most competition, the power supply is approx 12.12 volt. Sorry, not 12 volt, 12 volts. And in some cases, it will reach up to 14.8 volts in extreme cases. But at any time, at any point, the most basic bots are having the uh, power supply of 12 volts. Okay. Okay. Any questions here, guys? Any questions? Just let me know if you have any questions. Okay, and how many of you will register for the conquest? Just, just, just raise your hand or say yes, no, etc. Anything. Arsalan, Priyanshu, Sanskar. Just let us know in the comment section, guys. Okay, moving further. So these are the things you will require for your wired bot. Okay, now starting with, so we will not go into the date, but we will see the overview, how you can design your own bot. Okay, the structure wise, from the scratch. Okay, starting with the first chassis. How you can design your own chassis. Now, designing of chassis is very easy. Okay, just you have to see two things: weight, dimensions. Okay, first design the see, if you go for any competition now, for the ones you have like just like RoadRunner. Okay, you will see like RoadRunner for that. If you see for RoadRunner, there is given the dimension constraint and weight constraint, etc. Okay, go through the rules and regulation, design a bot on the 2D paper kind of something, design a 3D visualization into your mind, and then choose your chassis accordingly. Okay, now choosing of chassis is like choosing your whole body structure. Okay, you have to choose the best suitable one. Now you have for the chassis selection, you have to see the difference between sorry the distance between two motors actually. Since the motor is going to be in the parallel direction and not in the anti-parallel. Okay, one more thing, we will see it later actually after the chassis selection. Okay. Uh-huh. Since the motor is going to be in a parallel direction, you have to see how the chassis will look like, what's the perfect dimensions, what the perfect things. Okay. Since you have the dimension constraint, that's it. Now, development of chassis, you can easily make it through the plywood, as discussed earlier. You can easily go with the plywood and that metal chassis available in the markets, or with the that aluminum sheets. No issues. Going with the already pre-built chassis, you have to see if it's under your dimensions or not. Since some of the chassis were also available with the 40 centimeter or 35 centimeter of kind of widths. Okay, the extreme condition chassis were available with the 40 centimeters. So you have to choose your chassis accordingly. Okay, the next thing is motors. Now, selection of motors in your board is very important. Okay, it's like for the wired board, for either wired, wireless, anything, you have to choose your motor in such a way that it can tackle any obstacle comes into the your path. Okay, it has to tackle. Okay, going with the mindset of, let's like you have the mindset of going for the first prize. Okay, your bot is sufficient enough to tackle the whole obstacle coming into the arena. Now, most of the people, what they are doing is like they are just going with that locally available motors. It's like, okay, wait a bit. Hi everyone. Can you suggest a few motors? Okay, okay, we will see. Okay, we will see here only. Okay, so back to the track. Okay, what most of the people were doing is like they were just going with a normal 300 RPM DC motor available in the market actually. Okay, so what's the problem here? For the motor selection, you have to see, just like you have to just note it down anywhere if you can. Okay, for motor selection, you have to see the RPM, torque, dimension. Three things, and also weight. Four things: RPM, torque, dimension, and weight. You have to keep in mind these four things necessarily. Okay, without any doubt. Okay, going with the RPM. Now, what's the local vendors were having that second or third hand vendors motor? This are having the RPM of like 300 or 400 kind of something. Okay, in that actually, since it is a low grade motor, and now the original Johnson motor, and you can't compare the original Johnson grade or grade B motor with these kind of motors actually. Okay, they were locally not available probably, and with the available were having some kind of high prices. But the ones which are available in the market were having the RPM of 3 to 400, but it's not like it's 3 to 400 actually. It's jiggle about 200, 250, 350, something like that. Okay, so you have to keep in mind while choosing your motors. I prefer go with the online selection. Why? Because in online, just like in the online robotic shop, na, just like electronics comp, etc. They were having that original grade A or grade B motors. You can easily see the difference. Just get a motor from the robo or electronics firm and get a motor from that from the local vendors, like from any local vendor. Okay, just compare the speed and torque actually. Okay, you can easily find the difference. What the difference between them? Okay, so the normally available motors were three kind of motors we are simply using for our bots. Okay, one starting with BO motors. Okay, the BO motor is very popular among beginners. They were using like just it's like a slice of pizza for everyone. They were using like this only. Any question, guys? Okay, cool. Okay, so the normal BO motors is very popular among the beginners. Okay, but what's the problem with the BO motors is like now they were having, first of all, they were having very less RPM, and with less RPM they didn't have any torque also. So they were not capable enough to tackle the obstacles coming into the arena. Okay, so we are not recommending to go with the BO motors. The other one we can easily find in the local vendors also is the Johnson side shaft motor. Now, there are two kinds of motor. Okay, we are not going into the deep actually, but just an overview. There are two kinds of motors actually. Okay, one is center shaft motor and other one is side shaft motor. Now, what is the basic difference between center shaft and side shaft? Center shaft is having a high RPM, but some amount of low torque. Okay. Side shaft is having sufficient RPM but high torque. Okay. Now you have to see which uh, which kind of motor you have to choose to tackle the obstacles. Okay. For example, in any roadrunner, for example, in IIT Kharagpur, it's like what Sand Rover. Okay, Sand Rover event. There is in every robo race event there is an obstacle which is inclination, up inclination, some constant path, and then down inclination. Okay, so your bot is must be capable of moving up to the inclination. and the inclination is around a degree of 30 to 45. See, you have to move your whole structure into the up inclination of 30 to 45 degrees, and for that, you have to need a not RPM. The RPM is used for the smooth surfaces. When your board is moving on a smooth surface, on a plain surface, without any inclination or any obstacle, the RPM is sufficient enough. For the torque, you sorry, not for the torque, for the inclination parts, your bot is having the sufficient torque to tackle to go up to the inclination. Okay, in the with the local vendors, what they're having is they're having that 300 kind of RPM motors, the side shaft motor, which is very popular for the in the robotics world. Okay, that 300 RPM motor is it's having not that much of torque, but yes, with the enough power, you can use it, no, without any issues. So we can recommend you can go with that side shaft Johnson grade B, about 300 to 500 kind of RPM motors, which they are having that sufficient kind of torques. And if you have sufficient time, then we will prefer to go with that online shops such as the Robo Electronics from RoboCraze. Hell lot of shops are there. Okay, what we are using the other one. Okay. It's like let me tell you a brief story. It's like no. It's about five not five actually. It's about 10 days, 20 days actually before our first IIT Kharagpur event. Okay. We are discussing among ourselves and we got this motor by chance actually, and it's the last stock available in the Robo actually. So this is the motor, that orange motor. Now, orange is a product of Robo only. Okay, orange and lemon are product of Robo only. Now, what they are? This is OG 555 motor. Okay, I will share the link in the chat in the comment box. Okay, just a minute. Okay, okay, we will share it later. Okay, so, what we are using is OG 555 motor. Now, OG is a brand of OG is an orange brand made by the Robo. Okay, the 555 is it's from the family of RS775 motors. Okay, I think many of you. Okay, how many of you are using drill machines? You have seen drill machines or you have used that drill machine. Just comment it down. Hello guys, how many of you are using drill machines? Okay, cool. We have drill machines. Okay. Okay. Moving for okay. So, what does in the OG 555 motors now? They are having that base motor of RS775. Now, it's a high RPM motor. It has the RPM of around 18,000 to 20,000 RPM, and very less amount of torque. Now, for providing the enough torque, they have reduced the gearbox. They are the gearbox of around 2 to 3 centimeters, and they made a gear reduction to increase the torque from there. You can see in the presentation it is from center shaft orange motor. Okay, it's from the family of RS775 originally, and from the 18,000 to 20,000 of RPM, they have made the RPM to 500, and the motors is sufficient enough to tackle any obstacle come into its path. Okay, now it's around 12 volts motor, so you can easily use it. Moving further, okay, how to select the motors? Just now, moving further, now we are going to see a wire connection, circuit connection for the wired board. How you can make a connection for the wired board actually. Okay. Now, see, in the wired board only, if you could see, just a minute, we will see. Okay. I hope it's visible. Okay. So This is a kind of wired bot, which it's of the Robotics Society only. Okay. Now, how it's made actually? Let's see. So this was the chassis which we have made using the plywood, not plywood. It's actually a wood actually. Okay. So this is the chassis, and these are the L clamps. Now these are the shape of L clamps to hold the motors upon. Okay. We were using the screws to tie it upon to tie them. Okay. Now see the alignation. Okay, they are parallelly aligned. The motors are parallelly aligned in the chassis. Okay, now the posit now how this in a simple terms now this bot will run like see for the forward direction the all motors will move forward, for the backward all motors will move backward, for the left turning it's like a tank. Okay, for the left turning these two motors will move backward and these two motors will move forward for the left turning. For the right turning, these two motors will move backward and these two will lift forward. Okay, that's how it's like a tank type of bot. Okay, so how they have made it, it's like see they have centrally aligned the motors, connect the positive of these two motors together, and also the negative wires of these two motors. Positive of these two and negative same goes for this one. This also positive connection for common positive, common negative, common positive, common negative, and then they have sent it to the. This was the controller that they have sent it. Okay, for the wired bot in the bot only you just need this connection only. You just have to put the L clamps, the motors, connect the common ground, common positive voltage, common negative of the of right side motor. Same goes for the left side motor, and take out that common wire from here. Okay, from here now, this was the controller that we have designed for our wired bot. It's made up of DP-DT switches. Now, this is a DP-DT switches. It's like a three-pole type of switch. This one is the neutral point, first point, and this is second point. Okay, same goes for this also. The connection is like, as you can see in the presentation. Okay, see in the presentation, now this part is visible. This part is known as your DPDT switch. Like it's like a schematic of DPDT switch. Okay. So what will happen? Okay. From the center points. Now, as you can see, just a minute. As you can see, the DPDT switch is having that six poles. Okay. The center two poles, you were giving that power. One is positive, another one is negative. Now there is not any that you have there is no constraint that you have to give only this point is positive or this point is negative. You can use any point for positive or negative. Okay, from in this box they were giving positive to this point and negative from this point. Okay, connected these two opposite poles together and these two opposite poles together. Now, what will happen now? It's like, see, in the PPT, if you see, the battery's positive voltage is going through that center point of this one of a DPDT switch, and the negative point is going through that another center point of DPDT switch. Okay, the motor is connected to the lower points. Now, when you forward push the button, okay, the circuit will connect like this. It's like from the left side lower point to the middle to the right side upper point. It will connect. Okay. If you can see here, it's like circuit will go through, you have to give power to these 2 points from the positive. Suppose this is positive, this is negative. Okay, so these two are positive connection and these two are negative connections. So if you push the button like this, then it will connect the circuit to this point and this another point will goes to your motor positive direction and this other point will goes to your motor negative direction. Okay, now if you have any doubt, just let me know. Wait, you have any doubt actually? Okay, Okay, so back to the track. These two are power supply points, positive and negative. These two connect through a wire, and these two also connect through a wire. Okay, you have to take the output for the motors from these 2 points. Either you can take from these 2 points or these 2 points. One is positive, and the one is negative. Okay, when you push that button, the circuit will complete like this from this point to this point to this point. It's like a from it's kind of L type of shapes. Okay, see, it's like from here to here to here. Okay, and for the negative, from here to here to here. Okay, for DPT switches, you just have to make these only. Any doubts here? No. Cool, cool, cool. Okay, smart learners. Cool. Okay, moving further, coming to the wireless bot. It's very interesting part actually. What's the wireless ball? You can control from your PS4 controllers. You can if you played that PS2 or PS3, you have played that F1 racing. It's a game I can't remember actually, but there's a game called F1 racing. Okay, there you have to compete with a hell lot of other cars to your PS4 controller. Now you have to use that mindset, use that algorithms, use that other stuff to control the same car, but not in a virtual playground, in the real life playground. You have the arena, you have the bot, you can control your bot through your PS2 controller, PS3 controller. Okay, okay. So, as we discussed earlier, a wireless bot is kind of different from the wired bot. What's the difference? It has the motors, chassis, same as the wired bot, L clamp, same as the wired bot. But other than that, it has a brain of itself, okay, through which it you can program it itself to autonomously cover the whole track, whole arena by itself without any issue. Okay, the other thing, in the wired bot, we are directly pushing that buttons and supply the 12 volts or some voltage to the motors. Okay, but here you can control the voltage provided to your motor. Okay, in the wired bot, it's not your hand. It's not in your hand to control the voltage. But in wireless bot, you can actually control the voltage to in how much speed in how much RPM your in how much speed your bot should run actually. Okay, and for that, now since we are not directly giving the 12 volts or something voltage to our bot, so here we are using a motor driver. Now, with your brain actually, the brain is not much capable of to provide the enough power to your motors actually. Okay, so what we are doing is there is an additional some kind of circuitry like electronics which controls the motor. Okay, brain gives command to the that circuit, and that circuit will then run the motor. Okay, so the motor is depend upon that whole circuitry, which is known as your motor driver actually. Power supply, same as your wired bot. You can use 12 volts. The most basic one is 12 volts, and in some competitions also there is some voltage constraint. That is the voltage between these 2 points between any 2 points must not exceed that 12 volts or 14.8 voltage something. Okay, but here you can but the normal one we are going with the 12 volts. Okay, communication. Okay, for the wireless bot, you are not using that DPDT, you are not going to use that DPT switches. Okay, so what we are going to use, you can control your bot through your mobile phone actually. It's interesting. Okay, so you just have to download some kind of application, some kind of algorithms you have to use, some kind of coding and etc. And you are able to control your bot through your phone. The other one is you can control. Okay, how many of you are aware of the drones? Just comment it down. Okay. Okay. So you can either control your bot through your mobile phone, or you can actually control your bot with a drone controller. That the controller comes with a drone actually, the some kind of like a fly sky radio transmitter, and you can use a drone receiver to control your whole bot. Okay, we will see it later. Okay, just moving ahead. Now we have discussed about the motors. We discussed about the motor selection. We have discussed about that chassis. Now in this part, we since the additional circuitry which the wireless bot requires to control the motors is called motor driver. Okay, we are going to see what actually a motor driver is, not in depth, just an overview. So there are other hell lot of other type of motor driver available in the markets. Okay, it's like the most basic or the beginner friendly one is L293D. It's like a shield for your Arduino Uno. You just have to plug and play type of device. You have to plug, connect the motors, and you are ready to go. The other one is L298N. Just write it down if you are okay, if possible, just write it down. Okay. The other one is L298N. Some different kind of circuit. Okay, just let me show you. Okay. This one. This is a plug and play kind of device. Okay. It's called L293D. See, this is L293D. It's you have to just mount it on your Arduino Uno or any microcontroller or the brain which you are using, and you are ready to go. Now basically it's made for the Arduino Uno, so you have to that use that only. The other one is L298N. This is a red color type of wire, this red color type of your motor driver, and called as this is your L298N. Now, what's the difference between these two? This is very cheap. It's like a slice with no cheese. Now this has some kind of cheese, but very less amount of cheese. Now what's the cheese here? It's the cheese is the power, the voltage, not voltage, current consumption for your motors. Okay. Now see the peak current which it will supply to your uh, to your motors is like 1.2 volts, 1 point not volts, sorry, 1.2 amperes. Okay, and the peak current is 2 ampere for about 10 to 15 seconds. That's it. So okay, I strongly not recommend to go with this because this is hell shit. Okay, you can't use it. It's like you purchase it today, tomorrow it will bust without any reason. You can go with this. Okay, this is the red one. This is beginners friendly, but okay, you can go with this. The other one which we are using now, this one, this Citron MDD10A, the 10 ampere motor driver. Okay, see, this is a 10 ampere motor driver. Okay, now why? Now the pinouts, if you see, the pinouts of these two are same. Okay, just there is some four pinouts. Just there is some expandable. It's expanded pins. Okay, pinouts are approx same. Now, why we are going with this only? Selection of motor drivers depend upon your motors. What motors you are actually using. Now, in our board, since we are using OG 555 motor, going to the data sheet, we have found that the OG 555 motors we are using around 12 volts, and the peak current that they were using is around 4 ampere. Now, going with the worst case scenario, okay, always go with the worst case scenario. What will happen when your bot is at its peak? At its peak, how much it will consume the current, how much is the voltage consumption. Go with that only. You are in the safer side. Only that with that only. Okay. So going in the datasheet of the OG 555 motor, we have found out that the peak current that it will consume is like 4.5 amperes. So we have to choose our motor with that only, which can supply the 4 or max to max 5 ampere to a motor. Okay. Now, this red one, it's actually supplies that 1.2 amps. Now, it's a dual channel. What is it? Dual channel means you can connect two motors at a time. You can run the two motors at a time with this motor driver. Okay. Same goes with this one, this also. You can also connect two motors with this, two motors with this motor driver. You can run this, no issues. What's the difference? Uh, Current consumption. Okay. With this, the output current, the max output current is 1.2 amps, and with this, the max output current is approx 10 amps. Now, you can connect here. You can connect with in the red one. You can connect two motors at a time, and in single motor, the output will be approx 1.2 amps. Okay, so from this point, you can expect out power current output of 1.2 amps, and from this point, you can also expect a current output of 1.2 amps. But since our motor is of 4.5 amps, so we have to choose this. From it's also a dual channel. Now this channel is got broken, so we have shouldered it down. Okay, this is also dual channel, and that this part, but the current output is very high. Okay, from from this part, from these two terminals, the where you have to plug your motors, the output current is about 10 amps. This part and these two parts. Okay, this is like a broken one. Just okay. From these two parts, you can you can get the max output of 10 amps and also to 30 amps, but for the very less duration of time. But yes, 10 amps is sufficient for ourselves, so we go through this. Now in the local vendors, maybe it's not available in the local with the local vendors. So you have to purchase it online. With the local vendors is available, it's like a VN some kind of motor driver. It's also like this kind of motor driver, but the that VNHS, I can't remember the name actually. We will share the link in the comment box. Okay. The the other one is same as this one, but it has the red shape and a very huge HTM microcontroller, HT microcontrollers, not motor drivers, and with a peak current of 30 amperes they can provide. Which one is the best for side shaft motors? Which one is the best for side shaft motor? For see, for the it depends upon what specs of side shaft motor we are using actually. Okay, the general ones which we are using in our society is 300 RPM and with the current consumption of around 2 to 3 amps, peak 3 amps current consumption. So you can use this, but this will easily heat up in a very less duration. So for the safer side, be with this. Okay. I personally prefer this motor driver. This is best actually. Okay. Moving further, circuit connection of L298 and with UNO. Now, in this case, the brain of our bot, our rover, is Arduino Uno. You can use any other kind of brain such as Arduino Nano, Arduino Pico, Arduino Lilypad, anything. Arduino Pro Mini also, no issues. But the brain is this only. Now, using of Arduino is recommended for the since it is beginner friendly, and you can easily get it in the from any vendor in any robotics shop. Okay, this was the circuit diagram you have to follow while connecting your brain to your driver, motor driver. Okay, now the brain gives command to the driver, and driver will drive your motors accordingly. Okay, now from where you will to command your brain. Okay, since it is a wireless bot, you're far away from your bot actually. The arena is long enough. Okay, so you're approx you are in the outside or you are not in a direct contact with with your bot. Since you're using that RF kind of stuff or RF controller or that fly sky kind of controller, the drones controller if you're using, then there is a receiver actually. Receiver. Okay. If you could see it, just a minute. See, this is the receiver which we are using. Okay. This is the receiver which we are using for for our this bot. Now this is the FlySky FS 6B receiver, 6 channel. Go with the specs with the online, no issues. Okay. And this was the remote. which we are using. Now, from this RF remote, we will give the commands getting into this receiver, and this receiver will then the output of this receiver will then go to your microcontroller or your brain also, and the brain will then then make its decision, make its calculation accordingly, and then sends the command to your motor driver. Okay, so the coding and other part you can easily get it in the online stuff, no issues. There are a hell lot of tutorials to control your bots. Just search on the Google how to make a bot using FSI6 or Fly Sky remote. Okay, you can get hell lot of tutorials. Any query, guys? Could you zoom in on the receiver? Okay, sure. So this one is the receiver. This is the Fly Sky receiver, FSIA6B. It's a six-channel receiver. See, cool. Okay, moving further. Now, the communication protocol which we are using in a wireless bot. Okay, so a wireless bot, there are a hell lot of bots. You can control your wireless bot through your PS2, PS3, PS controller, PlayStation controller. You can control it through your mobile phone. You can make your own app and control your bot. You can use that drone receiver, fly sky receiver to control your bot. Any kind of controller you can use to control your bot. Okay, in this tutorial we are basically focusing on two types of communication: Bluetooth control bot and the RF control bot. Okay, so this was the circuit connection for a Bluetooth control bot. Okay, so this part, as you can see this whole part. This part is your transmitter part. Okay, and this whole part is your bot. Now, this is not assemble part, obviously. It's just a schematic diagram. Okay, this whole part, it's a replica of it's a replica of your bot actually. Okay, and this is your transmitter. Here is a joystick to control your forward, backward, left, right, and any kind of your bot, any kind of motion for your bot. It goes to your controller. Controller then programs it accordingly through the algorithm provided by you. It's coded by you only, and then through this Bluetooth module, it will send the data to the another Bluetooth module. Now, see what is here. Okay, this part is transmitter and this part is receiver. Okay, now here we are using two Bluetooth modules. Okay, one is using as a transmitter and the another one is using as a receiver. On the transmitter side, through a single joystick, we are controlling that whole bot. We are controlling the forward, backward, left, and right motion of our bot. From the data coming from the joystick going to your controller. The controller here, it is Arduino Nano. You can use any kind of controller. It's actually brain. Okay, and then the controller do its job, perform its algorithms, etc., and sends and tells your Bluetooth module to send the data to another Bluetooth module, which is available in your receiver part. Okay, which is a bot. Now, this part is your receiver. So in the receiver also, as you can see, there is a Bluetooth module which is receiving the data coming from the Bluetooth module of your transmitter. Okay, the receiver's Bluetooth module is receiving the data coming from the Bluetooth module of your transmitter. Okay, then it sends those data to your controller through your TX-RX pins, and then this is the brain for your receiver, and then the brain perform its algorithm calculations, etc., and tells the motor driver to run this motor or this motor, any motor. Okay, so from transmitter, you are sending the data through your HC05 to your Bluetooth module. In the receiving part, the Bluetooth module captures gets those data, For processing it, sends it's to the microcontroller, which is the Arduino Uno in this case, and then the Arduino Uno sends the data to the motor driver to perform the applications. Okay. Any doubt here? Any doubt? No. Okay. So it's understandable, or is the programming difficult? No, no, no. It's hell easy. It's very easy. It's like you can it's like you can program your own bot in about, if you just sit for the 2 hours, na, you can easily program your bot and your bot is ready to go. It's like that. Okay. Will you provide us this PPT? Okay. We will share it. Okay. No issues. We will share you this PPT. Okay. What is the programming code? Okay, just search on the Google. Okay, since we are discussing the Bluetooth control board, just search upon the Google. Okay, Bluetooth control board using HC05 language here, it is embedded C language. Okay, it's not like you can code it through you can code it through your Visual Studio, but it you have to code it to the Arduino IDE. There is an IDE used for controlling the for programming the microcontrollers used here. It's called as Arduino IDE. You have to program from that through that only. Okay. What is the programming code? Programming code you have to search. You go through the internet. There are hell lot of programming available. Okay, just search there. Bluetooth control board. Okay, just Bluetooth control board search there. You can easily get it. Also, na, what the interesting fact here is, you also don't have to make your own joystick type of transmitter. There is an online application available in the Play Store. Just download it and connect it with your Bluetooth module, and you're ready to go. So you just have to make your own bot. How did you learn programming? Okay. How did I learn programming? I just make the projects, and from that only I make the pro. Okay, moving ahead. So this is a circuit diagram for the wireless port. Okay, here also now in the Bluetooth control board, what we are doing actually is there is a the whole circuitry will remain same. Okay, see, the whole circuit will remain same. There is a joystick in the transmitter side. There is a joystick. There is a microcontroller as a brain, and there is a and in the receiver side, there is a motor driver, there is an external power supply to power up your motors. There is a Arduino Uno as a microcontroller or as a brain, and there is also motors. Obviously, there is a motors. And but what's the difference in the Bluetooth control board? There is two Bluetooth modules. Okay, the HC05 is a Bluetooth module which you have to pair to each other to transfer the data to communicate to each other. Okay, but in the in this wireless board, here we are using that NRF24L01. It's a wireless kind of chip, okay, and it's easily available in the market. Okay, you can get it at any robotics store. Okay, so here we are using that NRF24L01. So what's the benefit of using it? Now see, in the Bluetooth control board, na, many times there is a chance of losing the communication between the two. Now since most of you are beginners, so if you're going through that already pre-built applications available in the Play Store, there is always a chance that at any point of time during your run, you can easily lose the communication between your mobile phone and your bot. Okay, so what's the better thing? Just this one. It is known as your NRF24L01 module, and it's used for your long range communication. Now the coding part is a bit tricky for this one, but yes, you can easily do it without any issue. All the codes were available in the online sources. Just search it there. Okay, moving ahead. This was the circuit diagram for our radio control board, for a radio receiver. Okay. Now what's here is Here is no transmitter we have to make in the Bluetooth control board. Na, if you see, there we have to make our controller using a joystick and other microcontrollers such as Arduino Uno, Arduino Nano, anything else. And for the Bluetooth, we have to use another Bluetooth module, let's say S205. In the NRF, also we have to make our own circuitry for the controlling part. There is also a 9-volt battery, a capacitor, at some microcontroller, a joystick, and NRF module additionally. Now, in the radio receiver, it's like a Bluetooth control board where you have to there is no Bluetooth module, but there is a receiver like this. Okay, this kind of receiver is there, and you have to connect this receiver with your microcontroller. Here are the pins shown. These are the pins. Okay, so you have to connect these pins to your controller, and you have to use. And this was the radio. So this radio you have to use to send the data. Just just a minute. Okay. Okay. So this was the radio you have to use to send the data. You have to you can now you have to just use this part. Okay, for forward, backward, left, right, and this joystick will do all your part. Okay, it's kind of joystick also, but you don't have to program it actually. It's a pre-programmed device. Okay, how to identify which pin needs to be connected where? Okay, cool. For that, na, okay, what I have recommended, go through online resources. Online, everything is available in the online. Either that, just search on the Google how to make a wireless bot using a Fly Sky receiver, Fly Sky transmitter actually. Okay, just go through it. You can find every detail. Okay, there it will explain. It's a tutorial from Instructable or a drone bot workshop. I don't actually remember. Okay, okay. We will share the link. Okay, no issues. We will share the link after the meeting. At the end of the meeting, at the end of the tutorial, we will share the meeting. Okay, the description box. So you can easily find the pinouts, connections, how you can connect, how you can program your bot, etc. But what's the advantage from this? If you make your bot using this type of transmitter, now you just have to make your bot using Bluetooth kind of transmitter. And see, if you see in the Bluetooth part, just change your Bluetooth module with this receiver. That's it. Now the Bluetooth module, if you have used it, uses a TX-RX kind of pins. Here, this module is only uses that RX pin. Okay, to transfer the whole data. Okay, just go through the online resources. These are available. Okay, so this was the circuit diagram. Now, for bot making, na, just like see here, what we have designed is okay. So this was the bot which we have made using that same approach. Okay. We are using that this fly sky receiver. This is the brain what we are using. This is the brain. It is called that Arduino Nano, which provides the data, which calculates, use that algorithms to communicate, etc. All the things are processed by this controller only. And here is our motor driver. This is Cytron MDD 10 ampere motor driver, which we have discussed earlier also. Now, and this part here, if you could able to see, here is a small chip type of something. It's like BJT or MOSFET, but it's not actually a BJT. It's or neither it's MOSFET actually. It's a voltage regulator. Okay. Now, why we are using it? See, for the power supply, na, in most of our cases, they are going to use these kind of our batteries. These are LiPo batteries. These for 3S. It's like 12 volts LiPo batteries with about 2200 mAh power. Okay, so the output voltage is about 12 volts. Now this microcontroller will run at only 5 volts. So to drop down the voltage from 12 volts to 5 volts, we have to use this small part. It's called that voltage regulator. It's a 7805 voltage regulator, and it will convert your 12 volt input to the 5 volt output supply. So you can give that supply to your microcontroller, just Arduino Nano or any other microcontroller. Okay. Also, what we have discussed is the circuit part will remain as it is without any changes. Just the Bluetooth module will be exchanged by this small receiver. Okay. Just use this S bus part of receiver. You can easily find a tutorial in the drone bot workshop and or instruct table easily. Okay. And for the controlling of our bot, we are using this type of radio transmitters. Moving further, now this kind of interface, just search on the Play Store, Bluetooth control bot, the application for Bluetooth control bot. Okay, you can easily find the application, get it there, install it, and just connect the two devices with each other. Connect the phone with your Bluetooth device, and you're ready to go. Just plug and play type. Okay, okay. Now that's all from RoadRunner parts. I would like to. Any questions here, guys? Just let me know if you have any questions. Can you provide? Okay, link will be provided. Okay, thanks. This session is on. For the pins etc. You can easily find it on the website from the on anywhere online resources. You can easily get the tutorials. Okay, there are the hell lot of tutorials. Like there are instructable tutorials, drone bot workshop tutorials. You can get it easily there. Okay. Can you show coding environment? Coding is possible. Share. Okay, no. Just download that. Just search on the internet Arduino IDE. Okay. If you have done any type of coding in any Arduino related environment, you can easily get it. Okay. Or else there are the tutorials made upon this. In in the last in the last session, in the last part, we will share the link for the references and for the motors etc. in the description box, so you can easily get it there. Okay, coding environment is okay. We will share. Any other questions, guys? Okay.
So I am back. As you all know, I am Rohit Mundra. I think so. You liked the session for manual bot. So the next session will be by Ayandip Datta for line follower. So first, I would like to look at the chat section. There was one question that how the first years can join KRS. So I will tell you that joining KRS is not an easy process. Has not an easy process. It's a long-term process where you have to join our classes, pass the classes, then only you can join KRS. And the classes for you will be coming soon. Stay tuned with us in our YouTube channel. Like, subscribe, and share our YouTube channel as well as be in our Instagram, Facebook, and LinkedIn. You all will be getting that in our description box after the video live ends. how to join your non-tech team. Yeah, non-tech promotions will be starting soon, so you can join that non-tech team also. For we have different non-tech promotion, just like you can join for content team, operations, marketing, photography, as well as videographers, as well as graphic designers. So stay tuned with us and please join and please subscribe our YouTube channel. Thank you.
Hi guys, I'm Ayandeep and I've been a member of KRS for the last 1.5 years. So as you can see, we are gonna discuss here line follower, right? So let's go on. So you might be having a questions that is, what is a line follower, right? So what is line follower actually? Line follower, as the name suggests, it follows a line, right? Just two words, line and follower. Simply, a black line will be there on your arena, and your bot must be following it. Now, as like Purendra Bhaiya has been going on with his manual bot, you can also make a manual bot to cover up the line. But is that what's the point of the competition? No. So let's see how this line follower works. So the line follower will be a completely autonomous bot. All right, it can have two wheels, it can have four wheels. It will use the same system as a wireless manual bot, but the entire control will be given to the brain or the microcontroller itself. All right. So coming over to question one, what do you basically need, right? So as usual, you'll be needing a chassis. Then you will be needing motors, and for driving those motors, what will be needing? Motor drivers, right? So till now, we have been discussing motors, motor drivers, chassis. I'd like to show you them again. So as you can see, this is the chassis, right? This was a custom chassis. These are um, these are few motors inside. These will be wheels, and then you have your motor drivers, right? These will be common for the line follower as well. Just you will have a few changes with the chassis. Okay, so if I show you like pre-built chassis made of metal, this is the one. All right, so you can use this kind of chassis, or you can make a custom kind of chassis using any material you want. It must be hard enough to hold the entire structure together, right? So next what we'll be saying is IR sensors, right? So this is the new thing you will be discussing. This will be different from your manual bot. So you guys are aware that you have to follow a line on a path, right? So how do you think that you'll be following a line? Please, someone suggest from the chat. Anyone? Does no one have any idea how to follow a line? Okay, let me give you a hint. You let's say you are given a path and you have to follow it, right? The first thing you'll do is you will see where your path goes, and then accordingly you will be going on that path, right? So you'll be needing first your eyes for that. So what we'll be having for eyes here is the IR sensors, right? Okay, we have a like answer using sensors, a sensor tracking a trajectory. Okay, okay, guys, thanks for suggesting. So let me show you the IR sensors over here. So as you can see, these two are the IR sensors. Okay, these are some separate IR sensors. These have output pins and they take some power pins as well. You can connect them to the power supply as well as to your brain so that your brain can detect when these send any kind of signal. All right. You can also use a range or a set of IR sensors. This is called an IR sensor array. All the outputs of these sensors are given over here as well as the power connectors. You can see how many sensors you can have here. Let me count: 1, 2, 3, 4, 5, 6, 7, 8. Right. So these can be used for more complex paths. Right. We can use those. We have much smaller versions also here. This and these are the same, just the size is a bit smaller. Right. Okay, we have a question. Sensors which will move forward. Yeah. So Anirban Roy, you are actually on point with me. All right. So next we'll be saying that. So you have a black line on a white path. Okay. So using the sensors, these emit IR arrays, and also there are receivers for these IR arrays. All right. So when these IR rays are emitted, they will either be reflected or absorbed depending on the color of the surface. So you all guys know black surfaces absorb IR. So when the IR is absorbed, there will be no response on the receiver, and when the IR is reflected, there will be response on the receiver. Right. So that's basically the working of the IR sensors. Cool. Any questions? Anyone? Please keep the chat updated. So next we'll be using a microcontroller or a brain. So what we have discussed till now in the manual bot as well, you can use Arduinos, STM32s, or any kind of microcontroller that you feel you are easy to use with. After that, we'll be going over to battery and wheels. So for wheels, you can select any kind of, just we need to see that the wheels match the other bot specifications. Let's say you have a bot of around 10 by 10, right? 10 cross 10 centimeter cross 10 centimeter. So the wheels must be small enough for that, right? Otherwise, they will be bigger, and your speed will vary upon that. And if you have got a bigger bot, then your wheels will be accordingly bigger, right? And we'll be discussing about the battery. Okay, so since in line follower competitions, the size of the bots are not very big, all right. So the amount of current to be supplied or the amount of power consumed by the motors, they will be far less than what of manual bot uses. So we'll be using less strong batteries, and like if you are weaker motor drivers, we can use L293D. We can use these as well, L298N, and then we'll be using a few smaller motors. These you can see over here are 200 RPM BO motors, right? So you might, some of you might be recognizing these as these are commonly available, right? You can even use other kind of motors which are small enough, like there is N20 motors, there is normal DC motors. Okay, so we'll be going over to the batteries for one moment. You can use standard lithium polymer batteries like these as well. If you have got small enough battery packs or probably a lighter battery pack, you can use that as well. You can use lithium ion batteries as well. All right. So next I'll be going over to the circuit connections. Right. So actually, in this scenario, in line follower, the entire motor connection, motor driver connection, your microcontroller connection, these are completely similar. So you can connect four motors or two motors in parallel. You can use two motors in parallel or two motors as well to drive your bot. So the motors will be connected to the motor driver's output pins, and the motor driver should be connected to the power supply. And as you can see, these are the control pins. These will be connected to your microcontroller or the brain of your system, and your microcontroller will be controlling your motors using that. Okay. So what about the sensors then? We are using sensors to follow the line, right? So we can use, just like I showed you the previous board, there were two IR sensors. One will be connected to one of the pins, second one will be connected to another pin, right? So using these two sensors, we'll be reading whether the bot is going left or the bot is going right. Okay. Following over. Okay. Anyone has any questions? Mm, okay. Okay. Let's continue then. Okay. So so how does the line follower work? Simple thing. So we have discussed about IR sensors. We have discussed about motor drivers, motor chassis, right? So let's get into the details of the line following algorithm, right? So you can see over here. So first of all, let's say if your both of the sensors are on both sides of the line, right? Then both of them will be giving out the same data signal, right? That both of them don't sense the line. All right. So what is to be done then? If your path is straight, then none of the sensors will be touching the line. Then you should be moving your bot forward. That's what we have done over here, right? The bot is moving forward as a result. But what happens if the left sensor is touching on the line? So we must correct that, because the otherwise if the left sensor is touching on the line, that means the line is bending left. Other and your if your bot can't detect that, then it will go straight and cross over the line, right? So what we will do is whenever the left sensor will be touching the line, we'll be getting a signal, different signal on the left sensor. What we need to do is turn the bot to the left, right? And we'll keep on turning the bot to the left until we get the previous scenario, that is both of the sensors come on both sides of the lines. All right. So what if the reverse thing happens? If the right sensor is touching on the line, that means the line must have turned right. So what we'll do is we'll turn the bot to the right, so that the previous condition comes back, and this will be everything you need to design about the algorithm. So these are done with the two IR sensors. As when your track complexity, your competition's complexity will be increasing, you will be using more and more sensors. Like I showed you, 8 channel sensors are there, and you could be using those to detect more, let's say, thicker line or thin line. You can use those for complex track mechanisms. Let's say you have a plus sign that is to be detected, you can use the larger sensor arrays to detect that, for example. So that's all for the line follower. What we need to keep in mind for building a bot is we need to first get the dimensions of the bot, right? So the first thing we need to take care of the bot is, according to the competition we are going, we need to look very carefully about the dimensions given on the specifications, right? So if your bot is supposed to be for 20 centimeter cross 15 centimeters, then you need to make something just smaller than that or equal to that, so that you will be allowed for the competition. Next, we will be seeing the weight of the bot. If your bot is heavy enough, then your motors might be powerful enough to carry the bot. And if it's small enough, then you don't need those higher energy motors. Accordingly, your motor drivers will also be changing depending on the current draw. After that, we come to the motor selection. Like I said, your motor selection will depend on the weight of the bot. Motor driver selection will depend on the motor selection. And then we'll come to the power supply. Right. So I will go over next to one of the line follower bots we have on our display. Okay, so we do have a question. How to optimize the design? Can you please discuss? Yes, we will be. So there can be multiple types of optimization for the line follower, right? There can be optimization for speed. There can be optimization for accuracy. There can be optimization for different kind of problems in the track. Like I said, there can be a plus sign, there can be a T sign, there can be multiple kinds of sign which will be needing to detect. Let's say your track may come from one side and it may bifurcate into two, right? And then it may join again. There are multiple kinds of problems like this, and for these you need to um, optimize your bot. So if we go over to the speed optimization, then using different kinds of motors and manipulating the speed using your brain or the microcontroller will help in controlling your speed and optimizing it for the specific type of competition you're participating. Okay, accuracy is mainly a thing of the IR sensors as well as how well you're calibrating. So let's get into calibration a bit. So as okay, calibration is setting up your sensors to detect like the black line which you are given in the competition, right? Not all shades of blacks are equal, right? So what will happen is the let's say you have a practice track which you have prepared yourself for training your bot, then the shade of the black you have used will not be as same as the one you will be given in the competition, right? For this thing, we'll be needing to calibrate the sensors according to the shade of the black. All right. Okay. Next we'll be going over to the accuracy part, right? So like I said, there will be different kind of problem statements, right? And then there will be maneuvering of the bot, like turning it over to the left and over to the right. Like let's take an example. Let's say there is a curve on your track, right? So not all curve angles will be equal. It will not be curve. Some curves will be straighter. Some curves will be turning more sharply, right? So for that, your bot will be needing to adjust the speed and turning motion accordingly, right? So for these kind of problems, there is a system which we use, which is called PID, right? So what is PID? Like Hitobado Mondal here has mentioned. So PID is proportional, integral, and differential, right? So what does it do is it's an error correction method, right? So whenever the let's say the track, depending upon the curve of the track, since we are considering the curve over here, let's say depending upon the curve of the track, the line follower can detect which sensors are turning faster, and then accordingly it may use these values to correct the turning motion or the speed itself. Okay, it will be almost like a dynamically working system, not using fixed values. So using that we can correct the motion of the bot a lot. And then there are other things like there can be different kinds of sensors placed in different orientation, which may be used for like more accurate sensing of different pathways, like I said, plus pathway, cross pathway, etc. um do we have any other questions? Okay. So next we'll be showing two bots we will have on our display. I hope this is visible. Yeah. So like you can see over here, this bot has two IR sensors, right? These are connected to your brain or the microcontroller, and there are power connections as well. There are connections for battery. There is the motor driver on the inside, right? And we have used bio motors on this. We'll be coming over to another bot, which is we have used a custom chassis over here. It has 8 channel IR sensors. It has the microcontroller. It also has the same motor driver since we are not using very powerful motors also. So if we give a demo over here. So that's how you see a line follower works. It's simple, just a black line on a white surface, and your bot will be following that line, right? And depending upon your algorithm and how well you can adjust these different scenarios, your bot will be going forward or not. So that's all for the line follower. Um, so we have our contact addresses. in our presentation. Okay, so we are based in KIIT University, Campus 12, and you have our email address and phone number. Do contact us for any more queries. All the presentation, the code, and all the materials will be shared to you on this YouTube video in the description. So thank you guys for joining in, and we'll be meeting you soon in the event Conquest with your own manual bots and line follower robots. So thank you guys.